From analog.
Hi, Jim. You have a great signal up here. You're 5.9 plus.
To digital. We are everywhere you want to be. This is the CQ Blind Hams Podcast.
All right, good evening, everybody, and welcome to the CQ Blind Hams Tech Zoom for the month of August. This is where we get together, and it's almost like our version of having a radio group meeting, but not on the air, but it gives us a chance to talk to each other, learn more in depth about certain topics, and all, of course, from the blindness perspective. So if you want to learn more about the Blind Hams Network and the various nets that take place, and also find an easy link to this conference, you can go to www.blindhams.com, www.blindhams.com. And let's see, I think most of us who are here have been around, so I don't need to explain that we're being recorded and pressing got it and all that stuff. So let's get right to the thing here. So I'm going to go ahead and introduce the crew here. I know some of us are missing on the road and things like that. It is summertime after all. So we'll see what Joel, W0CAS, might have to say.
Good evening, everyone, and I would like to welcome Bruce to the CQ Blind Hams Tech Zoom. We're looking forward to his presentation tonight. Back to you, Julian.
All righty, thank you. Well, and Robert NC5R is in the midst of travel. I understand he's riding a steam locomotive or something like that. It sounded fun, but I guess that's why he's not here. So we'll go to Steve, WB2KTV. What's up in New York?
Oh, not too much. We're just coming off another almost heat wave, and tomorrow's going to be better. Or at least that's what the professional prevaricators and prognosticators say. Other than that, I'm looking forward to this presentation. I do not claim to be, nor am I, a Nano VNA user, because I don't have a lot of antennas, but I'm always interested in learning about new tools and tips, tricks, and technology, because I can always pass them on to someone else who doesn't know, and I always tell them, I don't have one of these, but this is what I've learned.
I agree, and it's also, I don't know about everybody else, but I particularly enjoy, even if it's not a subject that I think is of particular interest, if the speaker is very into it and makes his presentation with a lot of passion and enthusiasm, if nothing else, I can certainly enjoy that and the opportunity to learn about new things. So in the back here, we got Angelo manning the audio and the switches and all that good stuff. Angelo, you want to say a few words? N2DYN.
Good evening, everybody. Good to hear you in there. Bruce, thanks for doing this for us. I would have a little bit of an announcement. Yesterday, we had an organizational meeting to establish a club, which we voted on the names, and the majority picked Blind Amateur Radio Club, and the initials are BARC. And we're planning to get a club call, because Patrick would like that too for the bridge. And I'm working on getting an EIN and filing a corporation so we can get grants to do some research, maybe to keep these accessible radios going. And Russ is working on an accessible SWR bridge. So we got some good plans in the works, and we'll see where we go from there. Thanks a bunch, Julian, for hosting, being our MC again, and back to you.
Awesome. Thank you so much. And yeah, this is very exciting. And I'm glad that the cat can be let out of the bag, so to speak, because this is very exciting. I think it's going to be neat to have our own amateur radio club, and especially to do it for the purposes of helping to further amateur radio, especially in the blindness community. So this is exciting, and I'm sure we're all going to look forward to hearing more about that in the future as things take shape. So last but not least, me. My name is Julian. My call sign is N1CA, November 1, Charlie Alpha, here in Southern California, where it's currently about, 95 degrees or so, but Thankfully, our humidity is not as high. Our dew point's probably around 50 or so, so it's tolerable. And unlike a lot of people, I enjoy the heat, so this is good stuff for me. So without further ado,
Russ joined, by the way, if you want to let him say something.
Oh, sorry about that. Yeah, Russ, you want to chime in here?
I don't know if I'm. Can anyone hear me? I came in very late.
Yeah, we got you.
Okay, sorry. We had a very late dinner, and the service was a little slow. So yeah, this is Russ Can for MLR, and I'll be sitting on the side. Go ahead.
Awesome. Thanks for coming. Okay, so our guest speaker tonight is Bruce McKinnon. His call sign is KC1FSZ, Foxtrot Sierra Zulu, FSZ. Try saying that real fast. He's an extra class ham from Massachusetts. He's involved in various projects that you can learn more about. You can go to his QRZ page actually and learn a lot of interesting things. But to just briefly summarize, he's involved in projects that experiment with low power and low bandwidth radios, setting up mesh networks and things like that are really good resources to have in your local community, especially during times of emergency. So that sounds interesting, and maybe Sunday Bruce may come back and we can talk him into giving us a presentation on that subject, because I find that very intriguing. But the project is on GitHub if you want to learn more about it. And the other project that he's involved in that is of great interest here among blind hams is an HTML-based interface for the Nano VNA. And the Nano VNA, we've recently had a presentation on that one from Don, and that was a really good introductory thing. It certainly has gotten a lot of people more intrigued into wanting to play with these little devices. So this is something that was done as a collaboration with a member of his one of the clubs he's involved in. His name is Frank N1FNV, I think is his call. So they came together and collaborated on this wonderful project, which one of the nice things about it is that it is highly compatible with screen readers. So that means that us blind folks can use it with our screen readers on their computers and such. So it's always nice when things are made that accessible and that available. It has, of course, been used successfully by blind hams and experimenters. So I look forward to learning more about that. And that project can also be found on GitHub. So without further ado, I'm going to go ahead and turn things over to Bruce, and he can talk to us a little bit more about this Nano VNA stuff. And I'm looking forward to learning. Go ahead, Bruce.
Yeah, very good, gang. Thanks, thanks, Julian. Thanks, Joel, so much for having me over. And good. I'm glad we got some people interested in this topic. I'll just briefly introduce myself. I've been a ham since 2016, so relatively new, but I've been an electronics enthusiast since I was a kid. I tried the FCC novice license exam at age 10 twice, I believe, and failed both times on the CW portion. So that was it for me for a long time. Finally realized I could get through without the CW. Took my exam in 2016. I'm in now, so I'm a no-code ham, but I've definitely been involved in electronics and radio and software my entire life. I do some operating, but the niche of the hobby that I enjoy the most is the technology, the homebrew part of it. I've built most of the gear in my station right now. And when you're a builder, you're always on the hunt for cheap test gear. Because it's critical for trying to build anything. And that is what led me to the discovery of the Nano VNA, which we'll talk a little bit about this evening. I must say that I'm not an RF engineer. Anything that I know about RF electronics is self-taught. So if we have any legit RF engineers on the line today, you should feel free to speak up and correct any and all errors in my presentation. I was talking to Joel just at the beginning. This is an aside. I'm actually on vacation right now in Yosemite National Park in California at a extremely remote location. And the internet looks like it's going to hold in pretty good here, but as you can imagine, the coverage isn't great here. So I apologize if there's any glitches. But the one thing I'll say is that being out here in the wilderness, it's amazing to work HF in a place that's RF quiet. I turn on my radio, and you probably had that experience being in a quiet place. You're not even sure if it's working because the noise floor is so long. So low. The portable rig that I travel with is QRP. And last night I was making contacts on 5 watts with a lot of the big stations with no problem. So it's a great place to work HF if you've never been out here. And it's really actually been a lot of fun. So let's talk about the subject for this evening, which is the Nano VNA. And I've given quite a few talks about the Nano VNA, and people sometimes ask me if I have some kind of commercial interest in these devices. And the answer to that is no. I'm not selling the Nano VNAs. It's something that I'm interested in. And I discovered this just a couple of years ago, and I now own 3 of them. And I'll be happy to give any advice to anyone about the devices, but I'm not set up to sell them. So I'll just head off that question in case you're wondering about this. But things with the Nano VNA got a lot more interesting I guess it was about 2 years ago, when a local ham that you mentioned, Frank Ventura, N1 FMV, who's a member of the Wellesley Club up here in Massachusetts, suggested that we explore the capabilities of the serial interface that's been built into the Nano VNA in some more depth. And specifically, he was, as you mentioned, interested in the potential for other ways of pulling the information out of the Nano VNA to be used in all kinds of different ways, including more accessible user interfaces. So this led to a software product that does allow you to pull information out of the Nano VNA and format it in various ways, including the HTML interface that you referred to. So the idea for the Nano VNA controller program that you've been talking about came originally from Frank. He designed the layout. He's an expert on accessible interfaces, and he did all the testing. I wrote the code that drives this product. And I listened, this group has already had some excellent overviews of the Nano VNA from a user standpoint. I listened to Don IWC's talk, and I believe Georgina M0 EBP also had done a talk as well. So I'm not going to recover the ground that's been covered already in terms of how to use the device. I think there's really you guys have got some great stuff out there already that I can't improve on. But since we do have a more technical audience today, I'm going to provide some more technical information about what the Nano VNA is actually doing inside. And honestly, this is the part that I'm most interested in anyhow. So I'll just check for a second. Joel, is the audio okay? Are you guys able to hear all this fine?
Sounds good.
Beautiful.
Okay, excellent. Very good. So I guess no talk about the Nano VNA would be complete without a discussion about what vector network analysis actually is. And I can tell you, even from my own crude experimentation, that a VNA, a vector network analyzer, is one of the most important pieces of test equipment for an RF engineer. You really can't do anything without some form of this device. And until recently, a vector network analyzer was an extremely expensive device. This is something that you'd only find in a research lab or at a place where commercial hardware development was happening. I was doing some research for an earlier version of this talk and was just looking out on eBay at just some of the used equipment. And we're not talking new, we're just talking about used equipment. And there's a nice Roden Schwartz VNA that I had my eye on until I noticed that it was being sold on eBay for $18,000. So this equipment has traditionally been quite expensive. A very widely used HP, it's a Hewlett-Packard device, the HP 8753, which was extremely popular. It was originally sold in the 1980s. Even that machine is being sold for $1,000 used on eBay. So these things they're not cheap. I looked this morning to try to find the most expensive one, and I can find a Keysight VNA listed for $155,000. Keysight is, by the way, it's a new name for Hewlett-Packard. That's they got bought and they're rebranded. So that shows you how the high end is. And granted, the dynamic range of that machine goes up to something like 40 gigahertz. So that's a little bit out of range here of what the VNA can do, but just gives you an idea. And by the way, the 155,000 includes shipping, so it's not quite as bad as you'd imagine. But these have traditionally been very expensive, and it's even, I think, reasonable to compare the Nano VNA with devices that hams would be more familiar with, particularly antenna analyzers, which is pretty much the same idea. And even in this space, the MFJ 259 or 295? I can't remember, that a lot of people use is around $250 or $300. And some of the Rig Expert machines, which are really nice, you see that like on the high end, the Rig Experts, the ones that go up to 2 gigahertz are about $1,200 new. So, even in that space, these things aren't cheap. So the fact that any of us can go out and buy a vector network analyzer with pretty good performance for around $100 is a miracle in my mind. And I guess that's what drew my attention to this thing. So let's just talk a little bit about what vector network analysis actually means. And the basic idea is actually very simple. What a vector network analyzer does is injects a known signal into an electronic network, and then it watches what comes out of that network on the other side to provide some insight into the internal structure of that network. So I should clarify what types of networks we're talking about, because we're not talking about Ethernet or the internet. We're talking about electronic linear networks that would be typically found in radio systems. So examples would be antennas, feed lines, linear amplifiers, filters, attenuators, anything like that. And typically, the types of networks that we're looking at when we use a vector network analyzer fall into two categories. Either one-port devices, that's a device that sits on the desk and maybe just has one coaxial connector connected to it. So the best example of that, I guess, would be an antenna. That would be one category. And then the other category that's used quite a bit or analyzed quite a bit would be a two-port network, which is a device that sits on the desk and has two coaxial cables coming out, typically an input and an output. And a vector network analyzer has the ability to do analysis on both of these types. Now, I often get astute members of the audience pointing out that even an antenna is arguably a two-port device, because you have an input, which would be your feed line, and the output, which is what's being radiated into the atmosphere. But that's, I guess, that's true technically, but I guess for the purposes of this discussion, we should think about an antenna as a one-port device, because it just has one coaxial connector or some other types of cable hanging off of it. So the analysis that you do with a vector network analyzer follows those two models. There's one-port analysis, which is looking at a signal that's injected into the one-port device, and then also looking at what's reflected back out of that input port. And you'll all recognize that as the classic type of antenna analysis that we all do every day when we tune up our stations. We also have two-port analysis, which is putting a signal into the input of the device and looking at the output. And that's another class of analysis that can be done with network analyzers, and we do quite a bit of that as well. But in both cases, they're the same in the sense that we're comparing two signals. On one hand, we have the signal that we're putting into the device that's being tested. And on the other hand, we have the signal that's coming out of the device that's being tested. And the goal is to compare those two signals to get a better understanding of what's happening inside the box, so to speak. And when comparing two signals, we're really studying three different things in that comparison. We can study the frequency relationships between the inputs and the outputs, the amplitude or power relationships between the inputs and the outputs, and then finally, the phase relationships between the inputs and the outputs. And for the purposes of this discussion, we're dealing with linear networks, the typical types of networks that we would have on our desks as ham operators. So the frequency of the signal that goes in is the same as the one that goes out. Systems that change frequencies are a very interesting topic, but that's a topic for a different day. So when we're spending time using a vector network analyzer, what we're really trying to determine is the characteristics of the amplitude and phase relationships of things that are being put into the network and what's coming out. So we're focused on those two characteristics of these signals. And in the literature, you'll see the term S parameters often used to describe these things. S parameters, the ones that we're focused on today, S11 is the relationship between an input to a network and the reflection that comes back out. That's the antenna case. And then the S parameter called S21 describes the relationship between a signal that's put into a network and what comes out, the output of that network on the other side. And what the Nano VNA is doing, or actually really any VNA is doing, is providing a set of data that is characterizing the relationships in both amplitude and phase with the input and output signals of whatever it is that you've connected your network analyzer to. And in the case of the Nano VNA, that device has the ability to collect a set of samples. It's precisely 101 samples over a frequency range. And this gets to a very important concept when doing vector network analysis, which is it turns out that the relationship between the input signal and the output signal of a network that you're analyzing is almost always frequency dependent. And I think we would all recognize that. This is the reason why an antenna may be great on one band and bad on another, or it's also the same idea that allows a bandpass filter to attenuate unwanted frequencies, but allow other frequencies to pass through. It's because the network has a frequency dependence. And that's really the value of the vector network analyzer is it allows you to look at the relationships between inputs and outputs over a range of frequencies. And I think that's the important concept to keep in your mind as you think about what this device is doing, is it's essentially sweeping over a range that you get to decide, generating the input signal, and then as the sweep occurs, watching the signal that comes out and studying the amplitude and the phase of the output, and that's essentially what's happening inside of the box. And this description, I think, would be applicable for any vector network analyzer, running from the $155,000 version all the way down to the $100 version that we have in the Nano VNA. So that's just a very, very quick overview that gives you some sense of what the device is actually doing. And honestly, it's not that much more complicated than that. I will talk a little bit about the importance of phase, because generally we're all very familiar with the idea of the amplitude relationship between the inputs and outputs of a linear network. I just want to check, Joel, are you still with me?
Yes.
Excellent, good. I had a strange message pop up. I just want to make sure I was still in there. We're very familiar with the amplitude relationships of a network analysis, because that's what we see when we look at, say, the VSWR of an antenna system or the gain of an amplifier. So, the idea that we put in a voltage and then see the size of the voltage that comes back out again is the thing that folks would be most familiar with. The important thing about vector network analysis is that it actually allows us to study this problem in another dimension. And specifically, we're able to see not only the amplitude, but the phase of the output relative to the input. And this is critical because, as it turns out, you need to understand the phase relationship in order to fully characterize the impedance of a network that you're analyzing. And you're probably familiar with this, but just in case you're not familiar with the term phase, essentially the phase between two signals is comparing whether one of those signals is racing ahead or lagging behind the other in time. So networks that have lagging phase relationships are capacitive, and networks that are leading in phase relationships are inductive. So the key thing here, without getting into a huge amount of math that honestly I don't understand to begin with, is that being able to characterize the impedance of a device requires the ability to understand not only the device's impact on amplitude, but also the device's impact on phase of an input. And if you're interested in delving into this, I recently came across a book that really does a great job of explaining this relationship, and specifically, if you're interested in understanding the phase component of these types of analysis, specifically how phase enters into the picture when you're measuring VSWR or impedance. The book is entitled Reflections. I guess that's a probably apt title for a book on this topic. And it's actually written by Ham, Walter Maxwell, WTDU. And I highly recommend this book if you're interested in the mathematical underpinnings of this type of analysis. It goes into a lot of detail. It's pretty heavy going, but I don't know, I've pulled a lot out of it. Just one other interesting aside, I actually learned about that book from a person on YouTube who's a builder of CB amplifiers, 11-meter amplifiers. He has a fascinating channel on YouTube, and one of the interesting things I took away from that is it turns out that CBers are just as interested in the theory of RF as Ham. So anyhow, drop me a line if you want to get deeper into that fascinating world. That's a topic for another day. But anyway, the key takeaway here is vector network analysis depends on an understanding of not only amplitude but phase relationships. So now I'm going to maybe drill it a little bit specifically to the VNA that we're interested in, which is the Nano VNA. And the question is, how does that device actually work? Like, what's inside that tiny little box that you get when you buy one of these things? And it turns out that it's really a small SDR transceiver, literally. And the whole thing was magic to me until I actually got a look at the schematic for the first time. And if you, just tracing through what's inside that box, you realize that it literally is just a small and fairly simplistic SDR. And I'll just talk about some of the parts that are inside the box, just to give you a little sense of how it works. The transmitter side of the SDR is based on a chip manufactured by Silicon Graphics. It's called an SI5351. This chip is widely used in many radio products. I noticed by looking at the schematics that it's actually inside of some of the Flex products, and also inside of some of the Elecraft products. It's a frequency synthesizer made by a company called Silicon Labs. It's a very low power device, so it puts out a little less than a milliwatt. But that's the transmit side of the Nano VNA, and then the receive side of the Nano VNA actually has 3 very small receivers that are all running at the same time. The first receiver is listening to a copy of the transmitted signal, so it understands what's going out of the box in the analysis. The second receiver is listening to the reflected signal that's coming back on the input port of the device. That would be used for the S11 relationship. So that's what's being used to look at reflected power if you were studying an antenna, for example, to do antenna analysis. And then finally, the third receiver inside of this box is listening on the output port of the Nano VNA for S21 relationship. So you would use that if you were doing an analysis on, say, a filter, where you wanted to transmit a signal and then listen on the other side of the filter to see what came out again. So just picture a tiny SDR radio with 1 transmitter and 3 receivers, all hooked up inside of this thing. And a couple of components, if you're interested in more of the details, the receivers are implemented using a mixer chip, again, widely used, I believe, from the 1980s. It's called an SA612. I believe it was originally manufactured by Philips Electronics. I don't think they exist anymore, but this part is used in many, many radios today, and the mixer costs about 40 cents, so it's a pretty cheap device. The other important component inside the box that's used for demodulation is actually an audio codec manufactured by Texas Instruments. It's a mass market codec that you find in many, many laptops for providing audio input and output. It's an audio codec. It's called a TLV 320. The thing is about $1.50. So again, pretty inexpensive. And then finally, the brains of the device is a microprocessor. It's an ARM Cortex M0. It's made by ST Electronics, an STM32, which costs about $1. So you can see the total cost of the parts. I don't know, probably depending on how you get it, might be about $25 or $30 at the most. It's packed into a very small package for anyone who's tried to use this, and it has on it a very small LCD display. The LCD display displays a number of things, which I'll talk about in a second. But this kind of gets back to the reason why we started looking at this in the first place, is that the LCD, in fact, the original devices, is almost too small to be practical for some of the dense information that's being generated by this device. And so having external PC-based software that lets you pull the data out and look at it in other ways is critical. There's a very nice program out there called the Nano VNA Saver. I think you all may have had a presentation or two from people using that program. Very sophisticated program, more sophisticated than the Nano VNA controller for sure. And then the Nano VNA controller, similar idea. Any way you look at it, there's more information coming out of this device than can be conveniently crammed onto a 3-inch LCD display, at least in my opinion. So that's why so many people use the devices in conjunction with PC software. Let's see, a couple notes about accuracy. There's a lot of discussion about this on the internet. It's been measured by some professional RF engineers. It performs surprisingly well. The main differentiator that I can see between the Nano VNA and the commercial units that you're paying the big bucks for is calibration. And the calibration, I'll admit, on the Nano VNA is a pain, but it makes a big difference. And I've seen some discussion on the internet between RF engineers who suggest that more than half of the electronics that are inside of a commercial grade VNA are related to maintaining calibration, and specifically maintaining linearity across such a wide dynamic range. The high-end Keysight device I talked about goes from, I think it was 100 kilohertz all the way up to 43 gigahertz. So that's a massive dynamic range, and having a device that can maintain linearity across such a wide range is very, very complicated. So when you're getting your $100 Nano VNA, you don't have any of that. And the way you make up for that is using a calibration process. I would say that having spent a lot of time measuring these things, it depends on what you're doing. If you're just doing casual antenna analysis in the HF range, you can probably get away with a single calibration across the whole HF range, and it'll be just fine. If you're doing more detailed work, especially in UHF, the calibration starts to make a huge difference. And I know in my bench, when I'm doing work in UHF, I feel like I spend half of my time calibrating the VNA for the range of frequencies that I'm looking at, because it really does make a difference. So the accuracy is quite good, but there's no free lunch. What you're giving up by not spending hundreds of thousands of dollars on these devices is a clean automatic calibration system. Let's see, a couple other things I'll just talk about. I'm almost done here. As I mentioned before, the device has a display on it. What's the key to network analysis is showing a data set that's collected over a sweep of frequencies. So what you're getting here, almost by definition, is at least a two-dimensional view. On one dimension, you have the frequencies that you're studying. On the other dimension, you have the parameter that you're looking at. In the case of the VNA, what it's putting out natively is something called a reflection coefficient, which is essentially a characterization of the magnitude and phase of the signal that's coming out. That mathematically can be converted into a whole range of different numbers. And this is something that Don and I have been chatting about, because some of the software that's out there does the math to convert that reflection coefficient into a whole bunch of other things. VSWR would be the most common one, but return loss is another example, and complex impedance. There's a whole bunch of other ways that number can be expressed, but really it's the same piece of information, just being represented in a number of different ways. The thing that's quite interesting about this device is that people have come up with a lot of different ways of trying to help you to understand the data set that comes out of the machine. And one of the more complex views of magnitude and phase as a function of frequency was invented by an RF engineer back in the 1930s, a person by the name of Philip Smith. And he was actually also a ham. His call sign was 1ANB. So, and he's from Massachusetts. That's the one, they were using the one call zone even the 1930s, but he didn't, I guess they didn't start using the W's and the K's until later. I don't know, I'm not sure what that is, but his call, I checked it again, his call is 1ANB. And Philip Smith came up with an interesting way of representing this complex data set, which on one dimension is the frequency that you're sweeping across, and on the other dimensions are both phase and magnitude. And that chart bears his name. It's called a Smith chart. Again, I find it difficult to really understand that information on a very small screen. And one of the interesting parts of the research that we've been doing on the Nano VNA controller project is trying to think about different ways to present that complex data set. We've come up with some tabular HTML formats. Frank specifically proposed a few layouts, but I would invite other brainstorming on this idea because I'm sure there must be other ways to be able to present the pretty large amount of data that comes out of the serial port of the Nano VNA when you do a sweep. Let's see, a couple other things. I won't get into a lot of detail on this other than to say some people are interested in the history of the Nano VNA. As far as I can tell, the original concept was developed by a radio club in Texas, the Austin QRP Club, in 2010. Two hams, one by the name of Milt Cram and the other by the name of Keys Talon. Looks to me like had the original article that came closest to this device. But there were two breakthroughs that came from other people who are widely known only by their handles on GitHub, which is the open source software repository. One individual by the name of Eddie555 really back in 2012 created the base of the design that we now know as the Nano VNA, both the hardware and the software. And then it didn't seem to go too far until later in 2019, another person on GitHub with the handle of Hugin79 did some more work on the firmware. And actually, it looks to me was the first person to mass produce this device for sale. But what really made this interesting was, for some reason, which I'm still not completely clear on, a lot of people started cloning this device, particularly Chinese online marketplaces. And this led to a proliferation of different variations of the Nano VNA, all kinds of different varieties. If you've ever tried to shop for one of these things, I think you'll agree with me. It's quite frustrating that there are so many different variations. And I think this is the result of just massive amount of cloning from different manufacturers. And I guess the good thing about this is it's completely open source. So there's I don't think there's anybody who has any like ownership or commercial ownership of the intellectual property. And I guess that's kind of the spirit of ham radio, right? People have taken this and done all kinds of things with it. I've always been really impressed by the cooperation of different folks to create a device that now competes with some of the most famous test equipment manufacturers in the world. And yet this thing is being sold for in some cases less than $100. By the way, the same group of people have created a spectrum analyzer as well. This is called the Tiny SA. Very similar kind of ideas, very similar type of hardware. Another really interesting device. I have one of these as well. Very useful. That would be another presentation for another day. But just a note on the proliferation. If you've spent any time on eBay or AliExpress or Amazon, you know, I find it to be very, very hard to buy one of these things because it's just so hard to know what you're getting. There's so many different variations of it. There's the classic Nano VNA, there's the Nano VNA F, there's a Nano VNA H4, which has a bigger form factor, so the screen is bigger on that one. There's something called the SAA2N. There's a new one that coming out pretty recently called the V2H4, which claims to support up to 15 gigahertz, which is pretty amazing. I don't have one of those, but I'd like to test it. So it seems like there's at least 12 variations of this thing and more appearing all the time. And it just, the one thing that makes me wonder is why is there such a market for a niche device like this? And to me, it makes me wonder whether possibly they're being used in commercial labs instead of the high-end stuff. Because I mean, the ham, I'm sure there's a lot of hams with these things, but it's hard for me to believe that the hams provide a big enough market to justify people coming up with so many different variations and so much sales on the online site. So anyway, that's a mystery to be solved on another day. So I guess I'll just wind up here just to say that I have experimented with a couple of these things, but if there's anyone out there who's interested in trying one of these things, but is wondering how they would actually test it, I would be happy to buy one of your choosing and put it through my own testing, write you some notes and forward it along to you. So if you're interested, send me the link of the one you want to buy and Venmo me the money to cover the device and the shipping, and I'll be happy to check it out, including the compatibility with the software that I'm aware of, and let you know, send it along to you and let you know what I found out, because I'm always intrigued by the differences and the different variations. And I bought three. No three of them are alike, and they all have different strengths and weaknesses. So anyway, I think that's about enough. That gives you a good overview of the VNA and vector network analysis as well from a more of a technical standpoint. And I'll be happy to take any questions either now or an email. I'm good on QRZ. So maybe I'll send it back to Julian and Joel. But thanks so much for having me, and thanks for your interest.
Wow, that was quite a presentation. Thanks, Bruce. I'm still absorbing all of this, but it sounds interesting and a lot of fun. Joel, any thoughts?
Yeah, I've got a couple of questions. One is, have you run across or known of any of the Nano VNAs that did not work with your software? I have bought an Orson Nano VNA. I think it's 2022 version. Not got to test it yet, but it's still here in the box. And I was just wondering if there's any versions that you know of that will not work. Like, well, like you said, you haven't tested the very newest one you mentioned, the V2 version of the H4, I guess.
Yeah. Okay. So great question. So the answer to that question is yes. I actually did buy one that was not compatible with either my software or the Nano VNA Saver. That particular device I got about a year ago, and it was called the Nano VNA V2. That device is quite interesting, though, because as far as I can see, the designer of that particular model went to the most trouble of any that I've seen in creating RF shielded enclosure on the device. And so I'll tell you, the performance of the device is excellent. That's the one that I have that has the best performance, but unfortunately, it also is the one that doesn't talk to the software, because the serial, for whatever reason, I don't know why, the firmware on that model doesn't support the serial commands. I believe, however, that the V2H4 does support the serial commands that are needed to run the standard software, but I can't swear to that. And as I mentioned, if there's anyone who's interested and wants to, I'm happy to act as a middleman if you want me to test them out just to see what they do on the way to you. I'm happy to do that. But so I will just say that there are versions that do not work with my software, and I believe it's the case that anything that doesn't work with the Nano VNA controller software would also have the same problem with the other software packages, because the serial interface is not supported. But I would say that it's a shame, because that V2 box that I have is actually really nice and very rugged. It has a metal enclosure, and so there's a lot less noise in the system. Back over to you, Joel.
Got one more question that it's been brought up on the network a few times. You know, the versions are, 10 kilohertz or 100 kilohertz up to 1.5 or 3 gigahertz. Is it more accurate the higher the gigahertz, or is it just as accurate at 1.5 gigahertz in the 440 or 220 and HF frequencies?
Yeah, so a couple things about that. First off, the most important thing to think about when you're asking a question like that is the calibration. And there is essentially, when you're calibrating the device, you calibrate for a specific frequency range. And what I would just encourage you is, the more specific you can be about the range of frequencies that you're doing an analysis on when you do your calibration, the better off you are, because the device has essentially an internal correction that it's remembering during the calibration phase. And it's a pain because you have to switch. If you've gone through it, anyone who's done this will know immediately what I'm talking about. You have to, it steps you through. You screw on the 3 different standards that they give you: the open, the close, and the 50 ohm load, and then you connect the 2 ports together. It's a hassle, but it's quite important, because in order to have accuracy in the upper ranges, you have to make sure the device is calibrated for that. The other thing is, and this gets into more of the internals of the device, the way that the upper ranges are accessed is actually using the harmonics of the transmitter that are inside the box. The fundamental transmitter only goes up through VHF. And then the way they achieve measurements into the UHF or even the gigahertz range is by listening for the harmonics that are being generated by the fundamental frequency. This is a case where harmonics are actually a good thing. Normally we try to get rid of harmonics, but in these devices, they actually encourage it. And there is some loss of dynamic range the higher you go up. But the Nano VNA 2 that I talked about, I think, if I remember correctly, advertises a range up to 3 gigahertz. And I use it a lot for different UHF projects. In fact, the Mesh Network project runs on 900 megahertz. And I've had very good success with the 3 gigahertz rated device in that range. Pretty good accuracy and pretty reliably. So, I'm not going to be an expert on the latest and greatest specs, but I think if you're focused on calibration, I think you'll find surprisingly good results for such a cheap device. Back over to you, Joel.
One more question, and I know a lot of people's got 1,000 more, but so basically, if you're just operating in HF, and would you calibrate for every band that you're testing, or just calibrate one time for the whole band, and then when you go back and check, just say this 80-meter band, would you need to recalibrate? Or once you calibrate it for HF, you're good to go? What would your suggestion be?
Yeah, so I think a little bit of this depends on what you're doing exactly. I think if the goal is to make sure that your antenna is tuned reasonably, or if you're maybe cutting a new dipole, I think you could get away with a single calibration for most of the HF range. It's funny, things get a little different once you get up into like 12 meters and 10 meters. I've noticed. So I guess my rule of thumb is anything up through, say, 20 or 15 meters, I think you'd be fine with a single calibration. I actually worked on a 10-meter rig a year or so ago, and I noticed that the calibration needed to be specifically tuned up there. So I think it's just like everything else. It seems like 10 meters is always a little different because you're just on the edge of VHF at that point. So maybe my rule of thumb would be, from maybe top band up to say 15 meters, you're probably good with the calibration. And then anything above that, I would say probably it would be worth the time to recalibrate, especially if you're doing something like filters, or if you're trying to test maybe an amplifier that you have on the bench, and you're really trying to make sure that you have impedance matching done correctly. That's where the precision matters a lot more. Hopefully that answers your question, Joel.
Yes, it did. Back to you, Julian.
All righty. So does anybody else have questions for Bruce? If so, state your name and we'll acknowledge you and you can ask your question.
Yeah, I have a couple of questions, Don.
Yeah, go ahead, Don.
Okay, so one question I'm going to ask you is really a very stupid question, but I got to ask it. I think I know the answer, but I'm glad you're here, so I'm going to ask you. Why have you ever, well, I'll ask it this way. Have you ever calibrated a VNA and left out the open connector? I'm always amazed that, I think the answer to why they include it is because it's still noticed by the VNA as opposed to it not being there. But, when you think of these devices being manufactured, the bean counters, you would think they would argue to eliminate the open connector and just leave nothing on the antenna terminal, in port 1 or whatever, and be done with it and do the open calibration that way. Is it true that even though the connector is open-ended and there's nothing connected, it still shows up in the circuit? The VNA would know that it's there versus not there.
Yeah. So first of all, Don, that's actually not a dumb question at all. So a couple things about that one. First off, just probably like everything else in RF, these types of things matter more and more the higher you get in frequency range. So I think if you were doing something on 160 or 80 or even 40, I would probably say the difference is not going to be very noticeable. But the basic thing, and this is, by the way, if you're interested in this stuff, I would refer you back to that reflections book, because it's pretty dense, but it's definitely got the details on what you're asking about. But pretty much what it boils down to is anytime there's any discontinuity on a line, including that little open that's screwed onto the terminal of the VNA, that generates a reflection. It's surprising, but it's true. Any discontinuity in impedance, no matter how small, is setting up a small standing wave back in the direction of the generator. And so what they're doing with this calibration is calibrating that out. So I think if you were doing something on 2 meters, you would notice this. And it's surprising, but that's the reason that they give you that thing. And if you look at the kit, the 3 standards that they give you, the open is literally probably just an SMA connector, just with no wire connected to it. I mean, and what you're really calibrating for is the small reflection that's generated by the coaxial connector that you would normally have connected to a wire at that point. So, I've never quantified this, but I can tell you that in kind of high HF or VHF for sure, it's measurable. And they're not just, I think they're selling, if they're trying to sell the device to 3 gigahertz, no one would take it seriously if the calibration didn't include that feature.
Oh, excellent.
I hope that answers the question.
Thank you. Oh, it certainly does. It really does, and I really appreciate that. And my second and last question is, when you're talking about checking an antenna, like maybe a VHF or UHF antenna, it may not matter so much with an 80 meter or a 40 meter antenna, but maybe a VHF or UHF antenna. If that antenna is at the end of a foot of coax or 150 feet of coax, how much stock would you put in the readings that you're getting from a Nano VNA if that antenna is 150 feet away from the Nano VNA versus within a foot or two of it by virtue of a very short length of coax, given the fact that the original transmitted signal is already probably considerably weaker even as it's coming out of the SMA connector, and then it's got to go through 100 feet of coax.
Yes. Okay. So a couple things about that. So first off, I'm a QRP person, so like the low power thing is always surprising. But I mean, even the small signal that's being generated by the Nano VNA will travel a very long distance on a good piece of coax. So I think, to me, like 150 feet, you would definitely be getting good readings on 150 feet of coax. I wouldn't worry about that at all. I think you'd have to get to a much longer piece of coax before you might get to the point where the attenuation of the signal would be a problem. By the way, that's another place where you could probably use the calibration feature to work around that as well if you needed to. But I would say, Don, for like the length of coax that you would normally encounter for an HF station, I don't think you'd have any reason to doubt the accuracy of the thing on the end of the line. I think you'd have to have a much longer piece of coax to get into that problem, or maybe a much lower quality piece of coax. And I think with like open line, it's a little bit more complicated then, because you're getting into transformers. And I think at that point, the weak point in the system is not the ladder line. It's probably the transformers that you might need to worry about a little bit there. So there might be a different story. But if you're on coax, which is what the Nano VNA is designed for, it's built for a 50 ohm system. I wouldn't worry about a coax of that length.
But what about if you're talking 450 megahertz or something like that? I mean, even a good coax has got at least 3 dB loss at 450 megahertz, for example, and your signal is starting out at less than a milliwatt, and by the time you start looking at the harmonics, it doesn't seem like there's much left to get it to the other end of that wire without being just totally disappearing.
Yeah, so this gets into the sensitivity of the receiver that's inside this machine. And the dynamic, I don't have the specs in front of me, but you go take a look, and it has a very large dynamic range. The receiver, and especially the mixer chip that they're using, is a chip that's put into the front end of a lot of radios, and has the ability to do detection on very small signals. So I don't think losing 3 dB on a long piece of coax from the say the milliwatt or so output of the device, you would have no problems at all hearing that signal on the input side. You probably got my guess is, just rough numbers, maybe 50 or 60 dB to spare on that path. And
thank you.
It's really surprising to me too, and it took me a little while to get my head around how this thing was working. But I think what I would just encourage you is to think about it as an SDR, because that's what it is. And you wouldn't think twice about turning on the types of receive sensitivity that a normal SDR is capable of. You're resolving very weak signals. Maybe 80 dB down from a 1 milliwatt station without any problem at all. So it's a surprisingly sensitive receiver built from a component that's designed with that in mind.
Wow, excellent. Thank you very much.
All righty. Thank you, Don, for those questions. Anybody else with any questions for Bruce?
Yeah, this is Russ, CAN4MLR.
Yeah, go ahead, Russ.
Okay, when you staying with calibrations, there is a combo box that has 0 through 4, I think, or maybe 5, where you can store calibrations. So what I've done in the past is, with a multi-band antenna, I'll put like 40 meters in 0, calibrate it again for 20 meters, and then calibrate it again. Put them in each, in a different number on the combo box. Does the Nano VNA hold those calibrations after you turn it off? Now, I know you would, if it did, you'd have to go back to the same antenna. That's not a problem. I only have one. So, but do you need to recalibrate if you've saved calibrations in that combo box? Do you need to go back and recalibrate the next time you use it, assuming that you connect it to the same antenna?
Yeah, Russ, so thanks for that question. So the answer to that question is no, you do not need to recalibrate the device has non-volatile memory inside of it, as you point out, to save 5 sets of calibration. I say this just with a general caveat that there's not just one set of firmware. There's probably more versions of the firmware floating around than there are the hardware. But I've never seen any device, either any ones that I've had or any discussion on the internet of any that didn't save the calibrations inside the box. So you're good, and I think your system of like organizing, the presets based on the bands is a really good idea.
Thank you.
Well, hey, Russ, I want to thank you for that question, because that was actually, I was going to ask something along those lines, and I was going to call it a pre-newbie question, since I have not yet dabbled into this, but I'm becoming more intrigued as I go hear more of these presentations. And I was going to ask something along those lines, given the painstaking process that one goes through to calibrate, was there a place to at least store them, so next time you went to use it, you would be able to forego that? So that was a great question. I'm glad you asked it, Russ. So anybody else with any questions for Bruce?
Russ again with another question.
Go ahead.
Okay. This one first came up this morning on the Blind Hams talk group, and it involves the sequence of running the software. I have always launched the controller software, the .exe, and then launched the HTML. And the question came up is, does the HTML actually, is it able to launch the executable? And I haven't tried it yet, I haven't had a chance, but I'm really wondering if there is code in the HTML that could launch it. But that's the sequence that I've always used. Go in and I can just, click on it from the folder or shortcut for the executable. I get the message screen that comes up that gives you all the information about the COM ports and such, and Control C to end it. And then I go back and I've got a shortcut for the HTML, for the browser screen. Is it necessary to launch the executable first, or and just rely on the HTML file to bring it up, or is it indeed a two-step process?
Yeah, so thanks for that question, Russ. I wish, it's too bad Frank isn't here, because he could probably speak to this more. But basically, the process that you're using is the process that I use. I believe that there is not a way for the browser to launch the executable automatically. That would probably be a security problem, which they would probably stop you from doing. They don't. I think generally speaking, the browsers are designed to stop automatic launching of programs on your computer. So the way the program is designed, it's assumed that you've launched the controller executable yourself first, and then bring up the browser. Or you can start the browser first if you want. There's no problem with that, but it won't do anything until the controller program is running. I hope that answers your question, Russ.
Yeah, I mean, I think what's going on with some people are launching the browser thinking that it's working, and they see the layout and everything. Well, everything's there. You don't have to do any more, but they've probably never gone to actually using it.
Yep.
And I think that could be where the confusion is coming from.
Yeah, that could be. I mean, that executable is just a web server. So your browser is just talking to it. And so I think you're right. If you were to bring up the browser, it might even have in cache the last look at the page that it had, or maybe some default page. But without the controller program running, it's not going to do anything, because that's the bridge to the device through the serial port.
Well, there we go. Thank you.
Guys, right, I got time for one more, and then I'm getting called to dinner here, so I got to make sure how to wrap up here. So I'm happy to take one more.
Well, you know what? I'm going to go ahead and jump in here and take one, because it's kind of right along the lines of Russ's last question there. Has any thought been given to making this process possible on a mobile device like an iPhone or an Android phone?
Yeah, so haven't thought about that. I guess the trick here, and we'll have to think about this, and I'm definitely not a mobile developer, so I'll preface this by saying that, but I think having the mobile device talking to the controller that was running on a PC would be no problem. But the key thing is we have to come up with a way of getting the serial port connected. And what I'm not familiar with is if there's a way to deploy an application on a phone that can talk to the Nano VNA over a serial port. So maybe that question may be out of my depth. Honestly, I don't think anyone's ever suggested that, but it's pretty interesting. If someone could imagine, maybe someone who knows more about mobile development, how to set up the links, then that would be certainly something I could take a look at.
Okay. Yeah, because I mean, it's good to put it out there, because I think that would make the whole process even more portable, especially out in the field, things like that. And I know that a lot of us, myself absolutely included, live more and more on our mobile devices. And, these days I use a computer for very few things and very specific things. And any way that there is of taking something off the computer and on the mobile device, I'm all for it. So just throw it out there. It might be something to consider.
There definitely are two Android applications that supposedly work with the Nano VNA. I've looked at one of them and looked possible. So Bruce, I'll send you the info on it.
Yeah, that's great. Would love to see how they did that. That's interesting.
Yeah, because I think it'd be cool. I think it'd absolutely be cool. All right, Bruce. Well, we'll let you get going. We don't want dinner to get cold. So I want to thank you very much for joining us here, for giving us this wonderful presentation, answering our questions, and certainly getting us more and more interested in Nano VNA. So again, if anybody wants to get in touch with Bruce, you can find him on QRZ. His email's good there. The projects he's involved with are available on GitHub if you know how to get around there and navigate it. So thank you for coming.
My pleasure. Thanks so much for having me. 73s, gang. We'll talk to y'all later.
Thank you, Bruce. Maybe we can get you back on the mesh networking sometime.
Oh, yeah, I think that'd be cool.
Happy to do it.
7-3, Bruce.
Take care.
Take care. 7-3.
Don't forget to subscribe to this podcast and visit www.blindhams.com.